this session. Um, really excited to be here today to host my first event. Having some technical difficulties, to be honest, with the camera, so I can't turn that on right now, but I hope you guys can forgive me for that. Let me share my screen and we can get going. Can you guys see my screen? The slides? Okay. So today we're going to be looking at a ML text to image app using Stable Diffusion. We'll talk about Stable Diffusion a little bit more, but yeah, let's head on into it. So these are requirements for the event, like a minimum of 4 GB graphics card. You can, to be honest, run it without a graphics card. You can run this on your CPU, but it'll take a while. So this is why I just put it here, so you're not staring at your screen for like an hour or two just for an image. You'll need a Python 3.9 environment, and you'll need a the CUDA from NVIDIA installed on your PC, and you'll need a free Hugging Face account because we're using Stable Diffusion using Hugging Face's diffusers. And also, there's some pretty big packages we'll be using, so I recommend installing them if you haven't already. If you don't have any of that done, you can just get it. You can just do it while I'm rambling on here. So yeah, this is a beginner friendly event. I do have a pretty deep background in machine learning currently, but I'm trying to make this as beginner friendly as possible. And any lingo or machine learning lingo, I'll try to explain it along the way so no one gets lost. So yeah, while this does sound like a very complex thing, this text to image with machine learning, a lot of the functionality is encapsulated in Stable Diffusion. So we'll just be looking at it as a black box in terms of inputs and outputs. And I'll do my best to keep things simple and high level. So hopefully we can all enjoy regardless of technical fluency. So now that we got that out of the way, let's talk a little bit more about Stable Diffusion. Sorry, we're gonna look at what we're gonna do. So we're gonna create a text to image generator using machine learning with Stable Diffusion. We're gonna use Stable Diffusion and tkinter, and then we'll talk about what Stable Diffusion orders tkinter, and then we can go through the code. So Stable Diffusion. So Stable Diffusion is a deep learning text-to-image model released in 2002. It's used to generate images based on text descriptions, but it can do other stuff as well, such as in-painting and out-painting and generating image-to-image translations. And just so you know, like in-painting is like when you take a damaged photo and you can scale it back up and bring it back to a higher resolution. And if you guys have any questions, don't be afraid to drop them in the chat. So yeah, it's not only from Stability AI, it's from Stability AI and a bunch of other companies that came together to create this model. And it uses diffusers. So you're probably asking, what is a diffuser? To put it simply, if we want to look at it, a diffuser, what it does is it takes an image and then it puts a bunch of noise onto the image, and then basically once the image is fully noise, it'll try to reverse that noise into an image, and that's how they learn. I have a picture here, so you guys can see, like, it takes this image and it applies just as much noise as possible to it, and then it's basically trying to reverse this noise step by step by step, and that's how it teaches itself to create images. Yeah, that's how a diffuser works. Basically, super high level without any of the math or algorithms behind it. So tkinter. So tkinter, it's just a GUI development tool. You guys might have heard of it. It's standard in Python, so that's why we're going to use it. It's very accessible to everybody, and it just uses TK widgets, which is a fancy way of just saying windows and borders and buttons. So this is what the app we're going to build is going to look like. Just you can input a prompt to it, and as you can see, then Stable Diffusion will generate a image based on the text prompt. So we can look at some code right now. So these are just a bunch of imports, and then this is us creating the app. So this is just us initializing the tkinter app, and then telling Tkinter how big we want our window, the name of our application, and we want it in the dark mode. And then this is just where we want the window to spawn on our monitor or our display. Text, font, color, and foreground color. And then we are going to input a prompt in the window and a label in the window, which I can show you guys later. It's just going to say at the top of the window, just the name of our application. And this is going to be our model. So we're going to be using Stable Diffusion version 1.4, and device is CUDA. So that just means I'm going to be running it on my graphics card. So then we define our pipeline, which is Stable Diffusion pipeline from the Stable Diffusion model that we brought here. And then you'll see that I'm running the model in FP16 or float point 16. And that's because Stable Diffusion recommends that you don't run their model on a 32 float point if you have less than 10 gigabytes of memory in your graphics card, which I have less than that, and probably most people at home will have less than that. So we're using float point 16, and then you're going to put your authorization token from Hugging Face here so you can access the model. And then we are going to tell the pipeline that we're using CUDA. So that's basically the beginning of our code. This is setting up tkinter, and then this is just setting up our model. We haven't generated anything yet. So this is our generate function. So we're going to autocast our device, which if you remember, our device is CUDA, so it's our graphics card. And we're going to create an image. And our image is going to take our pipeline, which is Stable Diffusion version 1.4, and with all the other settings. And we're going to get our prompt, which our prompt is just going to be the text input to our in our application, basically in our window. It's going to be the text that we get from that button or that input. And then the guidance scale is just a fancy way of telling Stable Diffusion what we want. And then we're accessing it at the because when you use Stable Diffusion, it generates like a bunch of images. So we just want to get the first image. That's what this is saying. And then we're going to save that image and name it generated image.png so we can grab the image whenever we want. And then we're going to display the image on our tkinter application using image. And yeah, you can just see this is the way of telling tkinter we want to put an image in our application. Then we're this is our button called generate. So you'll see it in the application. I can show you. It's just this big blue generate button. So this is our prompt widget or tkinter widget, and then this is our big blue generate button that we're writing here. We just create, height, width, font, and then the background color is blue, and then the command is generate, and then we can create the text, put the text in the button that says generate, and tell the application where to put the button, and then we run our application at the very end of our code. So you're gonna have to have another file in your directory called auth token. You don't have to. You can name it whatever you want. You can even put it in your main. I just like keeping it separated, also so I don't show you guys my token because that would not be the greatest. So I have it in a separate file called authtoken.python. So whenever you see auth token, it's just referring to my authentication token that you can grab here from your Hugging Face account. So with that being said, let's look at some code, or let's look at the app. Okay. Let me share my screen again. So this is just my Visual Studio code. This is the code that we just looked at. As you can see, the code itself is very short. It's only 40 lines of code, and we're able to generate or create an application that you would think is extremely complex. But since we're able to look at Stable Diffusion as just a black box and a set of inputs and outputs, then this application becomes really simple. And that's the thing that I think is a big misunderstanding to most people, is that you need to have a great knowledge of machine learning to use it. You don't really need to know a lot about machine learning to use it. you can definitely learn more about it, but you can use machine learning. There's a vast array of just state of the art models that you can use either with a very cheap subscription or for free on the cloud. So yeah, this is a code that we had before and run my authentication tokens in there. And then I ran the app just by calling Python on the app. So then this is the app. I was trying to get a welcome slide to put up here, but as we can tell, this is a computer at the end of the day. So does anybody want to give me a prompt? Any prompt they want to see generated, and we can try it out in the chat? Rick Roll. Okay, let's see what Rick Roll comes up with. I'm getting Rick Rolled live. So we can see here when we call that generate, it will take a second because I am sharing and everything, but you can see that this request that we just put in popped up. Hopefully this doesn't break. I was testing it before. Okay. That is not supposed to be taking that long. Let's try that again. One sec. Let me just open it again. So I'm gonna go into my Python 3.9 environment because you have to use Python 3.9 for this, because we're using PyTorch and PyTorch does not support anything above Python 3.9. Just a fair warning if you do get some errors. Okay. So I can share my screen again. One sec. There we go. So we can just call python app.py. And then this is going to run our code. And then there is our application. So let's try Rick Roll again. So you can see that the application got it. There we go. Now it's starting. Wow, okay. That is not great. It's saying it's going to take 20 minutes. Hopefully that's not accurate. Did not think sharing this would make it, or streaming this would make it degrade so badly. Usually it takes like a minute or two to run. Yeah, 30 minutes is not a not a great time, huh? Let me stop sharing for a second. Let me see if that helps it. I can just share when the image is generated. But we can't. Oh yeah, that's way faster. Oh my goodness. Yeah, now it's predicting it's going to take 10 seconds. Okay, so I guess I just got to turn off my. It's nothing exciting. It's just going up on the command line. Okay, there we go. It's done. Okay, we actually got an interesting. What GPU am I running? I'm on a 3060, I think. Yeah, I don't know why when I was screen sharing, like when I turned off my screen share, it went from like 30 minutes to 20 seconds. So this is this is an interesting output. The reason we got a black screen or a black image is because the Stable Diffusion thought it detected a not safe for work image or NSFW image. You can see here, potential NSFW content was detected in one or more images. A black image will be returned instead. Try again with a different prompt and or seed. So um, let's just put Rick Astley never going to give you up. Hopefully that is not NSFW. Let me generate that again. Yeah, like right now it's saying it's going to take 11 seconds. I don't know why streaming it would degrade it that much. But I am using CUDA, so it could be trying to split up the GPU work, and my GPU is already okay. We got an image. So this is what Stable Diffusion thinks Rick Astley never going to give you up is looking like. It's very scary actually. It looks like yeah. A madman threw a stone in the well. 40 wise men could not get it out. Okay, let's try that. Copy. Yeah, so this looks like this is scary. We can generate that. Mid Journey was very successful with it. Okay, let's look. Let's see what Stable Diffusion can do. And then and again, also this application, right? It's just taking the first result. Like we could create an app easily. You could edit this app and create like a carousel and display. Okay, that is interesting. I don't think Stable Diffusion had too good of a time on this one. Let me share my screen. But then again, we're also not using the full Stable Diffusion model. We're giving it a guidance score so that I can run easily on our hardware. But this is the output it got. Which is interesting. I'm not sure what it was trying to pick up here. This okay, I don't know where like this looks like German maybe, like it was trying to write German. Yeah, it's very interesting output. I don't know if anybody else has a prompt. Does anybody else want to see anything generated? If not, we can proceed. The text is really clear for civil. Yeah, yeah, that is also yeah. This text itself is very clear. It does look like it just came off of a Word document or something. It doesn't look like a bunch of garbage. Yeah. Okay, so I guess no one else has any other prompts that they really want to see, so we can keep going with the slides. I'll just keep this open just in case someone has a last minute thing. So how can we use this? So there is actually some applicable use cases, and this is also kind of to tie in with the solution challenge. I don't know if you guys are aware of it, but the Google Solution Challenge, it's based off I think it's 17 or something like that, UN principles that, and you can basically create a demo, and then basically you can like the higher you place, like there's more incentives, and I think top people get to talk with like high ups in Google about their solution and stuff. So there are some use cases for this. So video game assets or any assets for that matter, like if you're thinking of developing something for a UI, you can like really just put something in there. Like actually, let's just put like health hack icon while we're talking and see what that says. So yeah, we can create assets. Also assisting artists, right? Because artists like artists and people like in that field like always get like writer's block or some sort of block whatever field they're in, and this can help them forward or go through that. And I think that's a misunderstanding that a lot of people get. They instantly think of, oh, how could this destroy, like, oh, this could just replace artists, and we're going to lose this whole profession. But you can also look at it in the way that it can assist artists. And I think that it, like, no matter how good these get, they'll never be able to really like kind of captive or capture that feeling that like actual art has from a human being. And I think that it's a really good tool for assisting artists, and that's kind of how we should try to look at it. And obviously, there's going to be malicious users with any and everything, so we got to kind of try to just put light on the positive use cases of it. It also, I was looking at this, it generated this guy, Walter Hugo Lopez Pena. They were able to use diffusion models, so what we were talking about before, from Dolly and Stable Diffusion, to generate 3D MRI images of brains conditioned on several covariates and make 100K synthetic brains openly available. So that is a really cool use case, of not only Stable Diffusion but just diffusion models in general. And then anonymization of faces, persons, scenes, and photographs for social media. So as I said, the in painting and out painting before, and in painting is that process of taking a noisy image or a grainy, pixelated, blurry image and bringing that up to resolution or up to scale. And I actually think Google is doing something with their new phones. Correct me if I'm wrong, but they're doing something with new phones and newer Samsungs where you can take a photo that you just took off your camera roll and de-blur it, or focus it even after you've taken the photo, which is really really cool. So that's in painting, I think. And then out painting, um, is when we take, it's like an anonymization of face, persons, or scenes. It's where we take an image and then we want to put noise, or apply noise to the image, or apply like static basically to the image, and anonymize, face, person, scenes, automatically for like interviews, police use cases, person privacy. Sorry, right? So that's another use case of the stable diffusion or diffusion models, generally, if you want to look at it like that. So that's the end. I don't know if anybody has any questions. Let me stop sharing so that health pack icon thing can go a little bit faster. Yeah, that's so weird. Right when I turn off it was at 10 out of 51, and I turned it off, and I'm already at 40. I'm not sure what that. It definitely has to do with CUDA and it trying to split up the workload across my GPU. So I don't know. Are there any questions? Does anybody have any questions? Thank you, Mehmet. I appreciate it. I can also share my screen here. This is actually really cool. So this is what it gave me for a health pack icon. I think that's actually really sick. It's very abstract, obviously, but you can see like kind of like if I was a game designer, I could like take the, I don't know what these two things on the side are doing, but you could kind of take that like if I wanted a responsive right health pack icon, I could just have this middle white guy, and then this is red when he's low, and then when he picks it up, it fills up and becomes green. Like that's just like an instant thought that I had. And I'm like, obviously, I'm not a game designer or anything. So it really can help people like get out of that blocked state when they're trying to create something artistic. Um, so yeah, I guess that's it. We did go pretty quickly. We finished in like 25 minutes. Um, if anybody has any questions, it doesn't even have to be stable diffusion related or AI related. If anybody has any questions, you can shoot them my way. Otherwise, I don't want to keep you guys waiting or keep you guys here. And we can end it there. So very cool. Okay. Thank you, Chris. Thank you, Christopher. Yeah, so I guess there's no questions, so I'm not going to keep you guys any longer than I have to. I appreciate all you guys coming out to my first talk. And if you have any questions about Stable Diffusion, I'm going to put this code up on the GDSC GitHub later. I'll drop a link for that when I get that done. So you guys can either look at it or just clone it directly and play around with it. But yeah, that's is there any way we can find data sets of any image to train models? So to my understanding, um, Stable Diffusion is built on, I think, the LAION database, the Laon, or however you want to pronounce it. So that's a data set that I know is is really good for training like these kind of models. I think it's like one of the largest like freely accessible data sets that you can use for this type of stuff. So I think, let me spell it out for you. It's LAION, and then I think the one specifically that even that Stable Diffusion used was the 5B. So this, I think. Don't quote me on this, and I don't know if it's free to use. I just know it's pretty it's accessible. But yeah, that's if I remember correctly, if I recall correctly, that's what Stable Diffusion used to train their own model. So it's a pretty good starting point. Yeah, no problem. So if nobody else has any questions, um, you can call it there. Yeah, as I said, I'll put up the code on GitHub, on the GDC GitHub, so you guys can just clone the repo and play around with it the way you want. I'd say maybe a next step is, or if you wanted to add something to the application, you could either create a carousel, so like you could scroll through images, or just create a bigger window with multiple images that show up. And instead of only calling the first element of the array or the list that has the images, you can call multiple of them, and then just either put them in a carousel or just display multiple pictures up on the application. So that's if you want to look at some next steps on how to augment the application and make it your own, that's what I'd recommend. So yeah, I guess there's no questions left. So you guys can head off. I really appreciate everyone coming out, and I appreciate all the questions and all the engagement. Thank you.